see things. Huh? Up to you, like, I mean, better if you write. नहीं लिखना शुरू कर दो अभी 10th में आओगे 9th वाला लॉजिक नहीं चलेगा better write बोर्ड लिखना है okay so it is a form of energy which enables us to see things right so basically let's say I'm able void just try to understand don't disturb it so how do we see things let's say you're seeing this board yes everybody sign the attendance those who in this sign it come so how do you see this pen can anybody explain the mechanism raise your hands wants to answer you're able to see this pen right why reflection of light because of the reflection of light so because there is a light falling on this object the light is reflected by in all directions because it's not that only you can see everybody the light is traveling in all the directions which light reflected light if I switch off the source of light and darken this room then you'll not be able to see any of them so objects are seen objects are visible when the light falling on them gets reflected and reaches the eyes of observer. That's when you see the object. So this is the basic mechanism how the objects are seen. Okay. So that means light is traveling from the source to the object and from the object to the observer, right? So then there is a concept of ray of light. So what is a ray of light? It is the path of light. Right? So when the light is traveling, it is traveling in a straight line, which is a straight line. So all these things you have actually studied in lower standards. Just a recap of all that. And what do you have? What is beam of light? Anybody? Beam of light, पढ़ा है? Yes. Yes. So it is a bunch of rays, collection of rays. So generally, when light is traveling, it's just not single ray. It is a collection of rays, right? So it is a bunch of rays traveling together. This called beam of light. Okay. Now we know that light travels in straight line. So we need to know the speed of light. With what speed does it travel? Tell me, what's the speed of light? What? Meter per second. Very good. 3 into 10 raised to 8 meter per second. So this is the speed with which light travels. How many meters that is, or how many kilometers? 3 lakh kilometers per second. Okay. And the symbol for speed of light is c. Okay. What is the symbol? C. It's a constant. C is the symbol for speed of light. Right. Now in this chapter, we are supposed to study about reflection of light. By what kind of surfaces? Spherical surfaces. Right. So in this chapter, we'll study about reflection of light by spherical surfaces. So first quickly revise, you probably have already studied reflection of light by plane surfaces. Have you studied reflection of light by plane surface? So reflection takes place according to a law. So let's revise laws of reflection of light. So what are the laws? What are the laws of reflection of light? Reflection. And so let us take a plane mirror, example of a plane mirror. So how do you represent plane mirror? Plane mirror consists of a plain polished glass surface. So one side is plain polished, the other side is coated, it has a silver coating, right? That is what forms mirror. One side is a polished surface and other side is coated with silver. Okay, this is a polished surface. This is basically a plane mirror. Plane surface. Now, any polished surface can act as a reflecting surface. Okay? I mean, can act as a mirror. Otherwise, all surfaces are going to reflect light. Anything that you are seeing, whether rough, can you see this? Is it very polished? No, but you can still see. So, all kind of surfaces reflect light, but when it is polished and coated with silver, we call it mirror. Okay. So, let us say light is falling like this. What happened?
So they put a stand out for that. And you can that's why it is
But it will stand for a lot of time. Who was that? Rupi madam or okay, so everybody try to be on time because otherwise they'll stop you outside. Attendance? Yeah, we can. So on the surface, let us say the light is falling obliquely. What is it? Oblique, inclined. So then, how to draw the reflected line? This is the incident ray, right? What is the angle of incidence? What is the angle of incidence? Wait, huh? Yeah, but I am still asking only what is angle of incidence? Who wants to answer? To draw the angle of incidence, first, this is the point of incidence. You have to first draw the normal, right? Heard of a normal? What is a normal? No, normal is the perpendicular drawn to the reflecting surface. Normal is a perpendicular drawn to the reflecting surface. So this is called normal. All these terms we are going to use in reflection of light by spherical surfaces. So that's why let us quickly revise this. Normal is it is a perpendicular to reflecting surface. At where is the normal? At point of incidence. What is O? Point of incidence. So what is the angle of incidence then? Angle between the incident ray and normal. So this is incident ray. So what will be angle of reflection? The reflected ray will be reflected by same angle as angle of incidence. Okay, so this angle will be R. Such that what is the law of reflection? First is angle of incidence is equal to angle of reflection. This is the law. Okay, so the reflected ray will also make same angle with the normal, but on the other side of the. Clear? This is law, first law of reflection. What is the second law of reflection? Yes.
The instant ray, the normal and the reflected ray lie on the same.
Same plane. Okay. So let us say. So what does it mean? At the point of incidence, we should say. So the incident ray, the normal and the reflected ray at the point of incidence lie in the same plane. So what is the plane? The plane is the board right now. All three rays are there. All three lines are in the plane of the board. Now imagine this is the plane of the board. So incident ray in this plane, normal also in this plane, reflected also in this plane. Now if I change the plane like this, around the vertical axis I rotate it, right? Now if the incident ray is here, normal is here and reflected is here. So it is in the same plane. Okay? Understood? So all three rays have to be in the same plane. Got it? Yeah. So this is reflected ray. Let me call this as IR. This is normal ON. This is reflected ray. I'm calling it as RR. So the second law is incident ray, normal, and reflected ray lie in same plane. So these are laws of reflection. Where in same plane? At point of incidence. So this you already know. Now next, properties of image form in a plane mirror. Okay, let us study that now. Now let us say this is our plane mirror. Let's call this as M dash. Now I have an object here. This is the object. So how do I show the image formation of this object in the mirror?
Same distance.
So image will be formed at the same distance, right? So let's draw the ray diagram for this. So how do we see the object? We see the object when the rays come from the object to our eyes, right? But we are seeing not this object directly, but in the mirror. So how to draw the ray diagram? So mirror will also see this object only if the rays of light are traveling to the mirror from it. Okay, so let's take two rays. These are the two rays incident. For example, there are infinite rays. Rays are coming in every direction. So I need only two rays to draw the image. Okay. So now apply law of reflection at this point. So you draw two normals. So obviously this angle is smaller and this angle is bigger. For reflection, I need a normal. So at the point of incidence, perpendicular to this will be like this. Okay. So this is my angle of incidence. So I construct a ray with an equal angle on the other side. Right? So this is my reflected ray, this is my incident ray. Likewise for this, I will have I dash and a reflected ray here also. This is R dash. Okay? So this is my reflected ray. And I am seeing this image from here. So where will be the image? Image will be obtained by extending this rays backwards. Okay, so equal distance. These rays are actually, it should be straight like this. So it's not drawn perfect. It should be straight, right? So the clue is, since the image should be obtained equal distance as the object is in front of it. So let us say this distance is x. Behind the mirror also it should be x. Okay, but the ray should be straight. So when you draw it with the help of scale, etc., you'll find that it is a perfect diagram. But this should be a solid line. This should be a solid line. Okay. So what we just saw is the image formation by plane mirror. The observer is seeing it from. Okay, so the image is formed same distance behind the mirror as the object is in front of it. Clear? So this is the image of object, so I am calling it O dash. Okay, so let's summarize the properties of images. First is image is formed behind the mirror at same distance as object in front of it. Image is formed at same distance behind the mirror as the object is in front of it. Now, what about the size of image? Same size. Right? Same size. When you look yourself in mirror, you don't look big or small, right? Same size. Image size is same as object size. Third, what is third property?
It will be virtual.
Yes, very good. It is virtual and direct. What does it mean? What is a virtual image? Direct means upright. Direct or upright. Means if the object is like this, image also will be same. Image won't be inverted. It is upright only. Okay, or erect. What is the meaning of virtual? Did you sign the attendance?
Yes.
What is the meaning of virtual? Anybody want to try? Okay, so I'll explain that virtual and real image. You have written this, right?
So he told me did not.
Huh?
It's the same one.
Yes, sir, I did right.
What about? No. Okay. So, what is virtual image? So write down. It is formed at a point point backward extended diverging reflected rays meet. I will explain first to write down. Now I told you the process of seeing things. How do you see things? When the reflected rays from the object reach your eyes, right? So these are the two reflected rays. What does the eye feel? I feel that these two rays are coming from here. But these are imaginary rays that you get when you extend it backwards. So the reflected rays are diverging, they are spreading out. It is called diverging. So when they meet like this, they are called converging. But when they go away, they are called diverging. So diverging reflected rays cannot meet because as you go ahead, it is going spreading further apart. So it cannot meet. But to this observer, it appears to him that these rays are coming from here. So when you extend it backward, where do they meet? Here. This is where the image will be formed. Which image? Virtual image. So this is not real image, this is virtual image. Got it? And where real image forms? Acha. One more thing is, this type of image cannot be obtained on screen. Virtual image cannot be obtained on screen. Okay? Like, suppose you are looking yourself in a mirror, you can see yourself. If you send your brother behind the mirror, will he see you? No. So that means if you keep any screen, you won't be able to produce this virtual image on the screen. Okay? So this is the second property. Then another type of image is called real image. Or now you write down what is a real image. It is obtained at at a point is mean or converge after reflection. Okay. So we are going to see real image in case of reflection by spherical mirrors. The plane mirror only has virtual image. Okay. So that's what we'll see. So wait for this. When we discuss reflection by spherical mirrors, that's when I'll explain this. Okay, one more property remaining. You should write this as by, not in. Write by. Yes. What is the last property? The image is laterally inverted. Right? It is. The image is laterally inverted. What does it mean? What is the meaning of lateral inversion? When you see your image, your left becomes right and right appears left in the image. So when you do the palm like this, the image will be like this. Okay? You can see this today in your house, or you can verify it like this. If you see letter E, the image, how the image will be obtained? So which is closer? This side is closer. So this will appear first. This is farther. So this is how the image will be obtained. Okay? Correct? So the image is flipped horizontally around the vertical axis. If you have a vertical axis like this, there will be horizontal flip. This is called lateral inversion. That's why ambulance, have you seen how it is written? It is written laterally inverted so that a driver driving the vehicle ahead sees the correct image of it. Okay? So, how is ambulance written? So, it is written like this. So, A is symmetric, M symmetric, no problem. Right? B should be written as like this. U is symmetric. So you must have seen ambulance is written like this, so that any vehicle driving in front of it, its reflected image will be seen to him clearly. Okay, so he'll be able to read it clearly, right? So you must have seen this. All right, so this is the basic introduction of chapter light. Can I erase this part? Everybody completed writing? Okay, so I'll erase this. All right. So we finished reflection by plane mirror. Now there is one more point. What is regular and irregular reflection? Irregular. Have you studied about it? What is it?
Regular surface and irregular surface.
What is a regular surface and what is a irregular surface? Let him try. Let him try. Let him try. Plane. Just like this glass.
Irregular like
some deformities. Yes, good. So your answer was different? Similar. Okay. So regular is a plane surface. Irregular may have some deformities like this. Okay, like a wall. So wall is not very polished. So wall would be like this when you see it with the help of lens, right? It appears, but it is not this much polished like a glass. Okay. So then what happens? So let us say there is a beam of light incident like this. So how to draw the reflected ray? Everywhere you draw a normal. So since these rays are parallel, the reflected rays also will be parallel. Okay, angle of incidence will be equal to angle of reflection in this case. So reflected rays also will be parallel to each other in case of regular reflection. What about this surface? Now let us say there are three rays in this case also parallel to each other, right? What about reflection in this case? Huh? How will you know? By seeing the nature of reflected rays, right? So apply the law of reflection. Law of reflection is applicable at all kinds of surfaces. So first you draw the normal. So what is the normal in this case? So the normal on a demo curved surface में क्या होता है? Now let us say this is a curved surface, right? So curved surface is only this much. Imagine it is part of some circle. Okay, so if this is the point of incidence, what is the normal? Normal is the radius. For a circle, radius always makes 90 degree with the tangent at that point. You know this? So suppose there is a tangent, so radius will always be normal to the tangent. So whenever you have a curved surface, the radius of the curvature, this is a curvature. And a curved surface is called, so any curved surface will have curvature. This is radius of curvature. So any line along the curvature is the normal. So imagine this is a curved surface, right? So imagine this is the normal then. Because you are imagining this is where the radius is, and you are extending radius little ahead, outside. Okay. So once you know angle of incidence, then you can draw angle of reflection equal to angle of incidence. Correct? By law of reflection. So this is the first way. I equal to R. That's what you have to do. Now for this surface, the radius will be inside because this is a curve like this. So imagine that this is the, okay, so the normal will be here. And you have to make normal as dotted ray. Why dotted? Because this is imaginary. Normal is something you are constructing. It's not present like the light ray. So light ray is real. So here the angle of incidence is bigger. Let's call this as I, this is I dash. So draw or construct a reflected ray of the same angle as angle of incidence. This is, so are these two reflected rays parallel? No. Now let's look at the third ray. Third ray again, this is the normal. So now draw, let's say this is I dash dash. Draw reflected angle equal to I dash dash. So this is R dash dash. So if this is 1, 2, 3 incident rays, the reflected ray is 1 dash, 2 dash, 3 dash. Are they parallel to each other? This kind of reflection is called irregular. Okay, it is also called scattering. Scattering of light or diffuse reflection. So many terms. Okay, so we'll study about this in later classes. There was a topic of scattering of light. I don't know whether it is there or removed. A lot of portion has been removed for you post corona. So what did you learn? What is the normal on the curved surface? This is the norm on curved surface. Is along the radius of curvature. So curvature is actually, if this is a circle, any arc curve, so it will have a radius of curvature, which is the radius. Got it? So we're going to learn about it in more detail when we will study reflection by spherical mirrors, which is the next topic. So this is the basic introduction to reflection of light. If you have any questions still here, ask us. Yes. Did I say something else? I showed it behind the mirror, but not mentioned it. And therefore the real should form. Where should the real image form? Huh? If virtual is behind, real should be in front. Yeah, exactly. That's what happens. Okay. So can I erase all this? Let's first understand spherical mirrors. So anybody has seen spherical mirrors? In a large car parking at the corner, have you seen giant mirrors? Okay, so that is an example of spherical mirror. Any other spherical mirror you have seen? That is lens, not mirror. What you are wearing is a lens. We'll come to lens later. That will be once we cover refraction of light. Right now we're discussing reflection. So reflection takes place with mirror. Lenses में क्या होता है? Refraction. That's a different phenomenon. We are yet to study that. Where else do you see mirrors? Vehicles. The vehicle mirrors are not plain mirror. Have you seen? They are slightly curved, like this. Okay, so let's understand spherical mirrors. There are two types. You have a mirror like this, and a mirror like this. So one is curved inwards, right? This is curved inwards. So reflecting surface is curved inward. Surface. Okay, so what is it called? Concave mirror. So in concave mirror, the reflecting surface is curved inwards, right? And this type of mirror is called convex mirror. So the reflecting surface is bulged outward, right? Bulged or curved outwards. Okay. So this is how it is. So what you're seeing is the edge of the mirror. How these mirrors are made? How are they made? Huh?
It's a part of the sphere.
Yes, it is made out of a hollow sphere, right? So suppose you have a hollow sphere like this. So this is the hollow sphere. So if you've got a mirror on this side, like this, and do a silver coating on this side, then what are you making? Concave. So this will make concave. And if you make a cutting on this side and do the silver coating on this side, what will be obtained is convex. Understood? Okay, should I close it? कौन सा है इसमें? ये वाला? So this is how the mirrors are made, right? Now there are certain terms related with mirror. Let's list down all the terms. One is pole and its symbol is P. Second is you have radius of curvature. First you had center of curvature. Center of symbol is C. Okay, then you have radius of curvature or principal axis. So that is radius of curvature. Now see, this point is the center of the sphere from which the mirrors were cut. Now this mirror, you can mark geometric center of these mirrors, like this point over here and over here. This is called as pole. Okay, so what is it? It is the geometric center of the mirror. The mirror. Okay, it is called pole. And C is the center of curvature. So what is it? It is the center of the sphere from which the mirror is cut. That is called C. So for every mirror, you will have a point C. That C is termed as its center of curvature. Okay? Now what is radius of curvature? It is this. The radius of the sphere from which the mirror is cut. So the line, this distance CP is called radius of curvature. Is it clear? So whenever we are referring to radius of curvature, it is the length CP.
What is total?
We'll come to it. We'll come to it. So technically to answer your question, it is the midpoint of radius of curvature. Okay, and what does it mean? We will tell you. So focal length is the distance FP. Okay, half of radius of curvature is focal length, and the point F is called focus or principal focus. So before that, let us understand what is principal axis. These are the terms that you will use while studying the image formation by spherical mirrors. So what is principal axis? The principal axis is the line that joins C and P. This is called principal axis. Okay, principal axis is a line that passes through C and P. That's principal axis. Then fifth, principal focus. Principal focus. Its symbol is F, capital F. So what is principal focus? It is midpoint of radius of curvature. Okay. So geometrically, it is the midpoint of radius of curvature. Then focal length. Focal length is PF. Its symbol is small f, and it is equal to length PF. It is given by R by 2, half of radius of curvature. What is radius of curvature? The CP is actually the symbol is R, and CP is the length of it. Okay, and F is length and PF. One more thing you note is the length is always measured from the pole. So radius is PC, you should write, not CP. Okay, length PC. I'll explain it again when we do the image formation by mirrors. One more thing is remaining. Should I erase this?
Yes.
Okay. So seventh is aperture. Okay, let me write it down. Aperture. Anybody, what is aperture? What is aperture? Any idea? Any guesses? Everything is in front of you. What is aperture in cameras? I'm sure you've heard about this term. तूने तो सुना ही होगा aperture. क्या होता है?
Lens.
लेंस तो अलग चीज है. Aperture क्या होता है? लेंस के अंदर aperture क्या है? यहाँ पे देखो, this is the aperture, the shutter which controls the flow of light inside. Exposure, right? Aperture से क्या control करते हैं? Light exposure. So how much light this mirror can take? This much? The edge, the full length of the mirror around its edge. So it is the diameter of the edge of the mirror. So if I call this as dash. So when you in 3 dimension, the mirror will be seen like this, like a bowl. So it has a curvature and it has an edge like a bowl, right? So this diameter of the edge of the mirror, this straight distance. Okay, so what is it? It is the diameter of the edge of the circular edge of the mirror, you can see. समझ आया? All of you have seen Terry dish? बोल तो है ना प्लेट. तो प्लेट कैसा होता है? उसका रिम सर्कुलर होता है and then it has some depression in which you keep stuff. तो ये ऐसा दिखेगा ना. So what you are seeing is only this part. Okay? अगर ये प्लेट है तो 3 डायमेंशन में तो ऐसा राउंड डिस्क दिखेगा. So diameter of the circular edge. Understood? Not this. This is not aperture. Aperture is straight from these two diametrically opposite points. The diameter of the edge. Clear? That's aperture. So light cannot enter more than the aperture. जितना aperture है उतना ही तो होगा. ठीक है? So that's what it is. So any confusion in all these terms? Okay, let's now discuss the ray diagrams. So how much time we have? Another 5 minutes. Okay, so we can complete one ray diagram. Okay. Erase it. Say yes or no. So you should write down everything on the board, okay? The things might be a little different. So this will be more helpful, conceptually. Okay. Next topic is image formation by concave mirror. Okay. So, what are the two types of images? Real and virtual. To form image, we require at least two rays. Okay. So, which two rays? So, we'll now discuss about that. So, first draw the concave mirror. So, in all the diagrams of image formation by mirror, this is the first thing you will do. Draw the mirror, mark pole, mark center of curvature, and draw principal axis. Okay. This is what you will do. And mark it. This is C. And also mark F. F will be midpoint of CP. How will you do in your notebook? Once you have drawn this, let us say the distance from P to C is 6 centimeter and F will be at 3 centimeter. And all distances to be measured from pole. That's a rule. Okay. So now what is focus? You see, whenever the ray travels parallel to principal axis. So we are not going to decide which rays to consider for image formation. One is ray parallel to principal axis. Now, what is the rule? Any ray that travels to parallel to principal axis. Now, this is the point of incidence, right? So, how to draw reflected ray? We need a normal. So, what is the normal? What is the normal on the curved surface? Yes, radius. I mean, I gave you that, right? The radius of curvature is this line. The normal to the curved surface is always radius of curvature. From that point to C, that is the normal. Now, once I draw the normal, I get the angle of incidence. Correct? Now I will construct the angle of reflection. So you will see that whenever the ray travels parallel to principal axis, the reflected ray always goes through focus. Okay? So this is the reflected ray. So this is one of the ray parallel to principal axis after reflection. Passes through focus. You may write principal focus or just focus. Okay. Then which second ray you will take? Second ray will be opposite to this. So any ray passing through focus, when it is falling on the mirror, the reflected ray will be parallel. Got it? So this is what is the second ray. Ray passing or incident along focus. Incident along focus after reflection. Comes parallel to principal axis. So what is the diagram now? Let us say you have a ray passing through focus. After reflection, it will be parallel to principal axis. So now, initially when I am telling you, I am drawing the normal everywhere. But once you know the positions, parallel has to always pass through focus. Then I need not draw normal all the time. So in this case, I have not drawn the normal. Right? Again, the normal will pass through C. Right? But now I know it is reverse of this ray. Right? So this is the second ray. Rest I'll tell you after the break. No, don't erase the board. I am leaving the volume.